Welcome to Science Excellence. Today I'm gonna start the series of lessons on the practice paper from the website MadasMaths. These are very good papers for the students who are doing Edexcel or AQA A-level mathematics. So these are the practice paper for the students year 13. So then after I'll start the series of lessons for the year 11, year 12 students as well. So the first question is, relative to a fixed origin O, the point A has coordinates 2, 1 and -3. The point B is such so that AB is 3i minus j plus 5k, and we have to determine the distance of B from O. So if we consider the origin O, and if we consider the point A over here and the point B somewhere here, and we connect them like that, then since the position vector OA has the coordinates 2, 1 and -3, so this vector is 2, 1 and -3, and the AB is given as 3, -1 and 5k, because you can see here AB is given as 3i minus j plus 5k. So if you write in this form, so the coefficient of I is 3, so 3, coefficient of j is -1, and the coefficient of k is 5, sorry, so it should be 5 only, not 5k. So we have to work out the distance of B from O. So for that we have to work out the vector OB first, and then we can work out the magnitude of OB, that will be the distance from O to B. So if we need to work out the vector OB, that means we have to use the triangle of addition. So if we need to work out OB, then it should be OA plus AB. So OB should be equals to OA plus AB. So if you add these two vectors, OA is 2, 1 and -3, and AB is 3, -1 and 5. So if we add the x coordinate with x coordinate, so 3 plus 2 will be 5, and if we add the y coordinate with y, like 1 minus 1 will be 0, and -3 plus 5 will be 2. So the OB is 5, 0 and 2. Now since we need to work out the distance of OB from O, so actually we need to work out the magnitude of the vector OB. So if you need to work out the magnitude of the vector, then you just need to add the ith component square plus jth component square plus kth component square, and whole square root will be the magnitude of that vector. So it will be 5 square is 25, and 2 square is 4, so 5 plus 4 is 29, so answer will be root 29. So that should be the distance of B from O. Okay, so the next question is, given that x is measured in radians, use a small angle approximation to simplify the following expression. In a small angle approximation, the formula sine theta is approximately equals to theta, and cos theta is approximately equals to 1 minus half theta square. So since we have in the question we have sine x, so sine x should be approximately equals to x, and cos of 7x should be approximately equals to 1 minus half 7x square. So we need to replace these values, these two values into, we need to put these values into the question, and then we have to simplify to get the answer. So the question is cos 7x minus 1 over x times sin x. So cos 7x we have to replace with 1 minus half 7x square minus 1 over x times this sin x we have to replace with x, so times by x. So this one and the minus 1 should be 0, and we're left with half. If you apply the square on it, we should be equals to minus half, and the square of 7 is 49 x square over x square. So x square and x square should be cancelled out from up and out, and the answer will be minus 49 over 2. Okay, so the next question is the sum to infinity of a geometric series is 3 times as large as its first term, and the third term of the same series is 40. So you know the formula for the sum to infinity is s infinity equals to a over 1 minus r. So where a is the first term and r is a common ratio. And the formula for any term of a sequence should be un equals to a times r to the power n minus 1. So we have to use these formulas to solve this question. The first part is find the value of the first term of the series, so that means we need to work out the value of a. So the question statement is the sum to infinity of a geometric series is 3 times as large as its first term. So if we consider s infinity, since the sum to infinity of a series is 3 times as large as its first term, so if you times by 3 to the first term, then this should be equals to s infinity, because sum to infinity is 3 times as large as its first term. So if you times by 3 to the first term, then both should be equals. So s infinity we know equals to a times a over 1 minus r, so we can replace our s infinity with a over 1 minus r equals to 3a. So this equation we can solve for r, because you have a and a on the denominator for both sides, so you can divide by a on both sides, and then a will be eliminated. We're left with 1 over 1 minus r equals to 3. If you take 1 minus r on the other side, so you're left with 1 equals to 3 times 1 minus r. If you take 3 inside, it will be 1 equals to 3 minus 3r. So if you take 3 to the left, so it's 1 minus 3 equals to minus 3r, and 1 minus 3 is minus 2 equals to minus 3r, and if you divide by minus 3 on both sides, so r will be 2 over 3. So this is the value of r. Now if we use the other condition which is given in the question, which is and the third term of the same series is 40. If the third term of the same series is 40, that means u3 should be a times r to the power n minus 1. So 3 minus 1 is 2, so its u3 should be equals to a times r power 2. So since the u3 is 40, it's given in the question, the third term is 40, So it should be, so u3 is a times r to the power 2, and it's given that u3 is 40 in the question. So in this equation, if you put the value of r, you will get the value of a. So it will be 40 equals to a times 2 over 3 to the power 2. In this formula, if you put the value of r from here, you will get the value of a. So 2 over 3 square, so this 40 equals to a times 2 square is 4, 3 square is 9, so it's 4 over 9. If you times this 40 by 9 and divide by 4, you will get the value of a. So if you simplify this, your answer will be 90, because 40 divided by 4 is 10, and 9 times 10 is 90, so the value of a is 90. Okay, so the part B of this question is determine the exact value of the sum of the first 4 terms of the series. So to find the finite sum of a geometric series, the formula for the finite sum of the term is Sn equals to a times 1 minus r to the power n over 1 minus r. So we have to use this formula to work out the sum of the first 4 terms of the series. So for the sum of the first 4 terms, we should put n equals to 4 in the formula. A we already work out in the previous part, which is 90, and r we also work out in part A, which is 2 over 3. So we have to sub these values into the formula and to get the sum of the first 4 terms. So let's do it. So Sn should be a times 1 minus r to the power n over 1 minus r, and we already work out a in part A, which is 90. R we already work on part A, which is 2 over 3, and n should be 4 because we need to work out the sum of the first 4 terms. So when you place your n with 4, it will be as 4. A is 90 and r is 2 over 3. N should be 4 over 1 minus r, which is 2 over 3. Okay, so it will be 90 times 1 minus 2 power 4 is 16 over 3 power 4 is 81 over 1 minus 2 over 3. So if you sub these fraction of numbers into the calculator, you will get the answer, and your answer should be 650 over 3. Now the next question is prove by contradiction that for all real theta, cos theta plus sin theta less than equals to root under square root 2. So if you have to prove by contradiction, so that means you need to consider the opposite, you need to suppose the opposite of the given statement, and then by doing some mathematical working out, you have to prove that the given one is like your supposition is wrong. So you can say by contradiction method the given one is true. So if we suppose the opposite statement, suppose that cos theta plus sin theta is greater than square root 2. As you can see that it's given cos theta plus sin theta is less than equals to 1. So we suppose cos theta plus sin theta is greater than 1, which is opposite which is the inverse statement of the given statement, right? So suppose that cos theta plus sin theta is greater than or equals to 1, then if you apply the square on both sides, cos theta plus sin theta whole square equals to greater than 2 if you apply the square on both sides. So squaring both sides, so then after, if you expand this square, either you can consider this cos theta plus sin theta 2 times and you can do term by term multiplication, or otherwise you can apply the binomial expansion. So then you will get cos square theta plus sin square theta plus 2 cos theta sin theta is greater than 2. So you know the identity, sin square theta plus cos square theta equals to 1, and we know the formula, like 2 sin theta cos theta equals to sin 2 theta, which is double angle formula. So if we use these two identities over here, you can see this is cos square plus sin square, so we can replace this with 1 plus 2 sin theta cos theta, you can replace with this one sin 2 theta is greater than 2. Now if you take your 1 to the other side, it will be sin 2 theta is greater than 2 minus 1, so sin 2 theta is greater than 1. But since we know that since sin theta is always between minus 1 and 1 for any angle, for any theta it always between minus 1 and 1, so it cannot be more than 1, so this is not possible. So it is contradiction to our supposition, so hence given statement is true. So this is a way to prove any result by using contradiction method. Okay, so the next question is, the figure above shows a circle of radius 6 cm, center at point C, and the straight line L which is tangent to the circle at point P. The point R lies on L, so you can see this point R is on the line L. The straight line segment CR, this straight line segment CR from here to here meets the circle at the point Q. Given that the length of the arc QP, this length from here to here is 2 pi. So show that the area of the finite region bounded by PQ, PR, RQ, QP shown shaded in the figure is this result. So actually the shaded region, we have to prove this shaded region is equals to this result. Okay, so first if we start with the arc length, this arc length should be equals to 2 pi, because it's given the arc length QP equals to 2 pi, and let's say this angle is theta, then the formula for the arc length is, let's say the arc length is L, it should be equals to r theta. So the formula for the arc length is L equals to r theta. So So the arc length is given as 2 pi. So if you replace your L with 2 pi, it should be equal to r theta, and r should be 6 because the radius of the circle is 6, so it's 6 theta. So if you divide by 6 on both sides, so theta should be 2 pi over 6, and 2 over 6 it means pi over 3. So our theta is pi over 3. And so next, if we consider this triangle, which is CPR, the bigger triangle, you can see you have the angle 90 degree over here, and this side is opposite to the 90, so it should be hypotenuse of the triangle. And since this angle is theta, so opposite to theta is this side, which is opposite, and this side is adjacent. So if we consider since this side is given, which is a CP is given as the radius, which is 6, and we can work out the PR, and since we know the angle as well, which is pi by 3. So if we consider the length CP, which is adjacent, and if we consider opposite over adjacent, opposite over adjacent will be 10. So tan theta is opposite over adjacent. So opposite is PR over here in the figure, and adjacent is CP. So PR we can work out if you put the CP is actually the radius in the figure, so the value of CP is 6 in the figure. So we can place our CP with 6, and theta is, we already work out, theta is pi by 3, so 10 pi by 3 is PR over 6. So if you times by 6 on both sides, then PR will be 6 times 10 of pi by 3, and 10 pi by 3 is actually 10 pi by 3 means 1060, and 1060 is root 3. So we can replace this 10 pi by 3 with root 3, so it should be 6 root 3, which is the value of PR. So in the figure we work out the value of PR, which is 6 root 3. Okay, so our objective is to work out the area of this shaded region, and it should be equals to this value, 6 times 3 root 3 minus 5, right? Okay, so now if we can work out that, because you know now you have the base of the triangle, which is 6, and the height of the triangle as well. The base of the triangle you can see is CP, which is 6, and the height of the triangle is PR, which is 6 root 3. So we can work out the area of the triangle, and from the area of the triangle, if you take away the area of this sector, which is CPQ, you'll get the area of the shaded region. Okay, let's work out the area of the triangle CPR. So the area of the triangle so it should be half times by the base, and the base is CP in the triangle, and the height is PR in the triangle, the figure, right? So if you sub the values we know CP is actually the radius of circle in the triangle. The value of CP is 6, which is given in the figure. And the value of PR we already work out, which is 6√3. Okay, so if we simplify this, 6 divided by 2 is 3, 3 times 6 is 18, so it should be 18√3. is the area of the triangle. So now we can work out the area of the sector CPQ. Now we have to work out the area of the sector CPR, this one. And formula for the area of the sector should be half times r square theta. Half times r square theta. So in the figure, r is 6, so 6 square, and theta is pi by 3. So 6 square is 36, divided by 2 is 18, and 18 divided by 3 is 6, so it will be 6 pi. So this is the area of the sector, 6 pi. So now in the figure you can see, if you take away the area of sector from the area of the triangle, you're left with the shaded region. So the shaded region so area of shaded region should be area of triangle, take away the area of the sector, and the area of the triangle is 18√3 minus the area of the sector, which is 6 pi. We work out 6 pi. Now if you take this 6 as a factor out, you're left with 6 times 3√3 minus pi. So this is the thing we have to show. Okay, so the next question is, the equation of a curve is given by implicit relationship x over x plus 1 plus y over y plus 1 equals to x square. So the implicit equation or implicit relationship means if x and y are so mixed up and you can't split in the form like y equals to f of x, you can't split in that form, so that means it is implicit. So if you can write y in terms of x, that means it's explicit function. So if the function is implicit and we have to differentiate it, that differentiation is called the implicit differentiation. So we have different ways to do it. We can simplify this one first, this equation first, then we can apply the derivative on this one, and on the second method can be like we can apply the derivative directly without simplifying. So I'm gonna differentiate directly this one. So the equation is x over x plus 1 plus y over y plus 1 equals to x square. So the students, if you have the fraction fraction of the polynomial fractions, so you have to apply the quotient rule. So the quotient rule is if you have, for example, if you need to differentiate u over v with respect to x, then it should be the square of v, then v as it is, minus derivative of u minus u as it is, derivative of v. So this is the quotient rule. So we're gonna apply this rule over here. The square of the denominator, then denominator as it is, then the derivative of the numerator, which is 1, minus numerator as it is, derivative of the denominator, which is 1. So we have to apply the same formula on this fraction. So the square of the denominator as it is, then the derivative of the numerator, which is dy over dx, minus numerator as it is, derivative of the denominator, it will be dy over dx. And on the right hand side you have x squared, so the derivative of this is 2x. So if you simplify this, it will be x plus 1 minus x over x plus 1 whole square plus y plus 1 dy over dx minus y dy over dx over y plus 1 whole square equals to 2x. So now this x minus x and x cancels out, you're left with 1 over x plus 1 whole square plus, if you take dy over dx as a factor out, you're left with y plus 1 minus y over y plus 1 whole square equals to 2x. So y and minus y cancels out, so you're left with 1 over x plus 1 whole square plus 1 over y plus 1 whole square dy over dx equals to 2x. Now we can make the dy over dx as a subject. If you take this whole term, this term to the right, so we will have 1 over y plus 1 whole square dy over dx equals to 2x minus 1 over x plus 1 whole square. This term was positive here, so if you take this to the right hand side of the equal, it will be negative. And then if you times by I want to eliminate this 1 plus y whole square from this side to make dy over dx as a subject. So if you times by y plus 1 whole square on both sides, so this y plus 1 square and this y plus 1 whole square cancels out, and you're left with dy over dx equals to 2x minus 1 over x plus 1 whole square times y plus 1 whole square. Now you can see dy over dx is a subject, and if we check the question again, we need to show that at the point on the curve with coordinates 1 1 the gradient is 7. So we can put the value of x and y from here, which is 1 and 1, to get the gradient. So if you find the value of the derivative gradient, you know the gradient is the first derivative. If you find the gradient at 1 1, so you need to replace your x with 1 and y with 1. So we just need to replace in this function x and y with 1 and 1. So we just need to simplify this now to show that this is 7. So 2 minus 1 over 1 plus 1 is 2, and 2 square is 4, so it's 1 over 4. 1 plus 1, this will be 2, and the 2 square is 4, so times by 4 outside. So if you take this 4 inside the fraction, so it will be 2 times 4 minus 1 over 4 times 4. So 2 times 4 is 8. Sorry, 2 times 4 is 8 minus 4 times 1 over 4 is 1, so 8 minus 1 is 7. So hence proved the gradient at the point 1 1 is 7. Okay, so next question number 7 is you have a figure, and the question is, the figure above shows the curve C with parametric equations x equals to cos cube theta and y equals to 12 sine theta, and theta is between 0 to 2 pi. The final region in the first quadrant bounded by C and the coordinate axis is shown shaded in the above figure. The curve is symmetrical in both the x-axis and the y-axis. Show that the area of the shaded region is given by this integral. So we have to prove that the shaded region is equal to this relationship. So if you consider this shaded region, let's say the point on the x-axis, this point is x1 and this point is x2, and for the parametric integration, this is, let's say, theta 1 and this is theta 2. And if we set x equals to 0 for this one point, at this point x is 0, so if you put x equals to 0 to find theta 1 in this equation, part of the parametric equation, if you put x equals to 0, because parametric equation is x equals to cos cube theta, so if you put x equals to 0 in it, it will be 0 equals to cos cube theta. When you apply the cube root on both sides, so it will be 0 equals to cos theta, and if you apply the cos inverse on the 0, then theta will be cos inverse of 0, and the theta cos inverse of 0 is either pi by 2, 90, and 3 pi by 2 in the domain 0 to 2 pi. So this is the acceptable limit, because at when theta is 3 pi by 2, if you put this in for the value of y equals, since y equals to 12 times sine theta, and if you put your theta here, which is 3 pi by 2, so you can check this value on the calculator, like sine 3 pi by 2 will be minus 1, so it is minus 12. So the value of y is minus 12, so y is minus 12 somewhere here, which is not acceptable because we are interested in the shaded region. So we should consider the value of theta as pi by 2 here. So theta 1 is pi by 2. Now for theta 2, if you put x equals to 0 for theta 2, y equals to 0 for theta 2, so we have y equals to 12 times sine theta, and if you put y equals to 0, it will be 12 sine theta divided by 12 on both sides, so sine theta equals to 0, and theta will be sine inverse of 0, which is 0, and pi in this domain 0 to 2 pi. But if you select theta as pi, and if you check in the other x coordinate, so x will be cos cube of pi, which is minus 1, so x minus 1 is somewhere here, but we are not interested in it, we are interested in the shaded region, so we should pick theta equals to 0 from here. So theta 2 is 0. Now we can use these limits theta 1 and theta 2 in our integration. So if we consider the area under the curve, for the area under the curve over here, the formula should be integral x1 to x2 from here to here, y f of x or y of x dx. This should be the formula for the area under the curve. So we can place this with theta for the parametric integration, so it will be theta 1 to theta 2 y of theta, and since you have dx, so you can apply the chain rule to write dx over d theta times by d theta. So we will use this formula to work out the area of the shaded region. Okay, so in this formula, if we put the value of y, since we know that y is 12 sine theta and x is cos cube theta. So in this integration we need the value of y in terms of theta, and we need dx over d theta. So if you differentiate this with respect to theta, it will be dx over d theta, which is 3 cos square theta. If you differentiate some function and there's a power on it, so you need to take the power at the front, take away 1 from the power, and without power derivative we need to work out, and we need to times it. So it will be minus sine theta, which is the derivative without power. So this is a complete differentiation of this function, which is minus 3 cos k theta sine theta. So these two values we need to sub in into the integral, and we have to put the value of theta 1 theta 2 as well, because we work out already theta 1 is pi by 2 and theta 2 is 0. So if we sub these values in over here, theta 1 is pi by 2, theta 2 is 0, the value of y is 12 sine theta, and the value of dx over d theta is minus 3 cos k theta sine theta d theta. Now if we simplify this, we will have integral pi by 2 to 0 minus of 3 times 12 is 36 cos square theta, and sine theta times sine theta will be sine square theta d theta. So we have one property of the integral. If you have negative sign, integral b to a f of x dx, then it will be equals to a to b f of x dx, which means if you remove the negative sign and you flip the limits, upper limits and lower limits, then these integrals are equal. This is the property of the integral. So if you apply this property over here, because we have the negative sign outside, so if you remove the negative sign and flip the limits, you will get this result. And 36 is a constant you can take outside, so it will be 36 times cos k theta d theta sine square theta d theta, and this is the result we have to show for the part A. So in the part B we have to prove use trigonometric identities to show that cos square sine square theta equals to 1 over 8 times 1 minus cos 4 theta. So we have to start from the left hand side, and we have to prove the left hand side equals to the right hand side. So on the left hand side we have cos square and sine square. So for this we need to use the identities. Cos 2 theta equals to 2 cos square theta minus 1, and cos 2 theta equals to 1 minus 2 sine square theta. These are the two different results, which is actually the cos double angle. Since you know cos 2 theta is cos square theta minus sine square theta, and you should also know that sine square theta plus cos square theta equals to 1. So if you want to work out this formula, you can replace this sine square from here. The value of sine square will be sine square theta equals to 1 minus cos square theta, and this value you can place over here. So it will be cos square theta minus times 1 minus cos square theta. Value of sine square you can place from here, and then if you take negative inside, it will be cos square theta minus 1 plus cos square theta. So cos square plus cos square will be 2 cos square theta minus 1. So similarly, from this identity, if you put the value of cos, you will get the formula in terms of sine. Okay, so from these two identities, we can make the value of sine square and cos square, and we can sub back over here, and then we have to do some simplification. We need to apply some algebraic techniques to get this. Okay, so first we should make the cos square theta subject from this one. So if you take minus 1 to the left, it will be cos 2 theta plus 1 equals to 2 cos square theta, and if you divide by 2 on both sides, then cos square theta equals to 1 plus cos 2 theta whole divided by 2. So this is the value of cos square theta. So similarly, from here you can make your sine square theta as a subject. So if you take minus 2 sine square to the left hand side and cos 2 theta to the right hand side, so it will be 2 sine square theta equals to 1 minus cos 2 theta, and divide by 2 on both sides, then sine square theta equals to 1 minus cos 2 theta over 2. So this is the value of sine square. Now if you can see this, which is cos square theta times sine square theta equals to 1 over 8 times 1 minus cos 4 theta. So if you start from the left hand side, you can put the value of cos square and sine square now, since the left hand side of the result is cos square theta times sine square theta. So the value of cos square we can replace with this value, 1 plus cos 2 theta over 2, and sine square theta we can replace with this one, 1 minus cos 2 theta over 2. Then it will be, if you do the term by term multiplication, in the denominator you will have 4 because 2 times 2 is 4. So it will be 1 over 4 is a plus b and a minus b. So if you remember from GCSE, like it is the you can change into the difference of square because it is a plus b times a minus b. So 1 square will remain 1 minus cos square 2 theta. So this is the multiplication. Otherwise you can do the term by term multiplication, you will get the same answer. Now the problem is we have cos square 2 theta again, and we should have 1 over 8 times something. So we can use this result again. If you replace your theta by 2 theta, like if you change your angle, so if you replace this theta by 2 theta, then this angle should double as well. So over here you will have theta, so it will be 2 theta now, and this was 2 theta, so it will become now 4 theta. So the value of cos square 2 theta should be 1 plus cos 4 theta over 2. So we can sub this value over here. So it will be 1 over 4 times 1 minus 1 plus cos 4 theta over 2. So if we do the simplification inside, we can consider 1 as 2 over 2 minus 1 plus cos 4 theta over 2. I just wrote this 1 as 2 over 2, which is same as 1, to make the same denominator. So 1 over 4 outside as it is. Now you have the same denominator, you can write in a single fraction, so it will be 2 times 1 minus cos 4 theta, because you have the negative outside the fraction, so when you take this inside you have to change the sign. So now it will be 1 over 4, 2 minus 1 is 1 minus cos 4 theta over 2. So if you take this to it outside, it will be 1 over 8 1 minus cos 4 theta. So this is the result we have to show. So now we have the part C, which is hence find in terms of pi the total area enclosed by the curve C. So you can see in the figure the total area enclosed by the curve C is like the 4 part of the shaded region. Like, we already work out the integral equation for this shaded part, and we have the 4 parts of this kind, and this shape is symmetric. So we just need to times by 4 to that integral to get the total area of the shaded region, because we already work out the integral relationship for this shaded part, and this shaded part is same as the other the total parts are 4. So that integral equation we should times by 4 to get the total area of the curve enclosed by the curve. So in the part A, we already proved that the area of the shaded region is integral 0 to pi by 2 36 times sine square theta cos square theta d theta. This was the area of the shaded region, and you can see in the total figure, the total curve, we have the 4 parts of the same kind, and the shape is symmetric. So if you times this integral by 4, you'll get the total area of the curve C. So now, and in the part P, we already work out sine square theta cos square theta equals to this result. So we can replace the cos square sine square with this one. So it will be 4 integral 0 to pi by 2 36 times sine square cos square you can replace with 1 over 8, as we proved in part B. 1 over 8 times 1 minus cos 4 theta and d theta. So if you work out 36 times 4 divided by 8, it will be 18. So you will have 0 to pi by 2 integral 18 times 1 minus cos 4 theta d theta. So now you can take 18 inside, so you will have 0 to pi by 2 18 minus 18 times cos 4 theta d theta. So if you apply the integral on it, so it will be 18 theta minus 18 sine 4 theta, and the derivative of the angle you need to divide outside, because the integral of cos 4 theta is sine 4 theta, and the derivative of the angle is 4, so you need to divide by 4 because we are integrating, and the limits you need to apply now, which is 0 to pi by 2. So now if you sub the upper limit, actually before applying the limit we can simplify this. It will be, if you divide by 2 up and down, it will be 9 over 2. So now if we sub the limit, it will be, upper limit is 18 times pi by 2 minus sine 4 theta, 9 by 2 sine 4 theta means pi by 2 as well. So this is upper limit minus lower limit, which is 18 times 0 and minus 9 over 2 sine 4 theta of 0. So if you simplify these limits, you will left with 9 pi from here, and minus 9 over 2, 4 divided by 2 is 2, so sine 2 pi, and minus 18 times 0 is 0, and sine of 0 is 0, so this will be 0, and sine of 2 pi is 0, so you left with actually 9 pi, which is the answer. So this is the total area of the curve C. Okay students, the question number 8 is a curve C has equation y equals to 1 over x cube plus 1, x belongs to R and x is not equals to minus 1. Determine an equation of the curve which is obtained by translating C by the vector 3 and 1. So if you are translating the curve 3 units across, if you have x and y axis and you are going 3 units across on the x axis and 1 unit up on the y-axis, that means in the function you need to take away 3 from f of x and you need to add 1 to f of x outside the function, because inside the function, let's say this curve is f of x equals to 1 over x cube plus 1, then f of x equals to 1 over x cube plus 1. So since this is a given curve, so since we need to move this function, we need to move the curve against this function at 3 units to the right and 1 unit up. So in the f of x, if you have x minus 3, then you need to do the opposite operation with the x coordinate. Like if we inside the function, if you take away 3, that means we have to add 3 to the x coordinate of into the function against the curve. So if we have to move 1 unit up according to the vector, that means we have to do the same operation with the function. So if there is addition of 1 in the function, that means we have to do the same operation to the y coordinates of the given curve. That means we need to add 1 to the x y coordinates of the given curve. So it should be addition of 1 outside the function and we have to take away 3 inside the function. So we always need to do the opposite with the x coordinate and the same operation with the y coordinate. So if there is addition outside the function, so that means we need to add 1 to the y coordinate of the given curve, and if there is if they take away 3 from inside the function, then you have to do the opposite operation with the x coordinates against the curve. So according to this factor, our function should be f of x minus 3 plus 1. So if you apply the same into the given function, then it will be, we need to replace our x with x minus 3 whole cube plus 1, and we need to add 1 to the curve, and this should be the new function according to this vector. So the next part B is describe fully a sequence of 2 transformations which map the graph of C onto the graph with the equation y equals to 1 over x cube minus 1, x belongs to R. So you can see the given function is f of x equals to 1 over x cube plus 1, but this one is y equals to 1 over x cube minus 1. So if we replace our, let's say this is equals to again f of x, and if we replace x with minus x, let's say let's replace x with minus x. So if you replace your x with minus x, so the function will be f of minus x, which is 1 over minus x whole cube minus 1, so it will be minus x cube minus 1. And if we times by minus 1 to the function after, then it will be minus times minus f of x equals to minus times minus x cube minus 1. So if you take negative out from the denominator, so it will be minus x cube plus 1. So this minus and minus cancels out, and you're left with 1 over x cube plus 1. Sorry, if we consider the given function f of x equals to 1 over x cube plus 1, and in the given function this should be positive, because in the given function we need to consider the given function here, and we need to replace x with minus x in the given function. So it will be f of minus x, because we need to change our given function into this form, 1 over x cube minus 1, and then we'll see what transformations we got when we switch this function into this function. So if you replace your x with minus x into the given function, then it will be f of minus x, and then this x you need to place with minus x, so it will be minus x cube plus 1. So it will be at the end minus x cube plus 1. Then if you times by minus 1 on both sides, then you will have minus 1 over minus x cube plus 1, and this should be negative when you take negative outside, and then negative and negative cancels out, and this will be again negative, and you will end up with this one, y equals to 1 over x cube minus 1. So you can see we times by minus 1 inside the function and we times by minus 1 outside the function. So this is the reflection about the x-axis followed by the reflection about the y-axis. So it's a reflection about x-axis followed by the reflection about y-axis. So this is the answer for question number 8. Okay, so the question number 9 is f of x equals to 3x squared minus 18x plus 21, x belongs to R and x is more than 4. So we have to express f of x in the form of a times x plus b whole square plus c, where a, b, c are integers. So we should complete the scale in this case. So if you consider f of x equals to 3x squared minus 18x plus 21, and x belongs to R, x more than 4, then the first step of completing the scale should be we should take 3 as a factor out, and you can see 3 is the divisor of all the numbers. So if you take 3 as a factor out, you're left with x squared minus 6x plus 7, and then after we have to consider the half of the quotient of x, and it will be minus 6 divided by 2 is 3, so it's x minus 3 whole square minus the square of the half, which is 9 plus 7. So if you do 3 times x minus 3 whole square minus 9 plus 7 is minus 2, and if you take 3 inside now, it will be 3 times x minus 3 whole square minus 3 times 2 is 6. So if you compare this with the given one, a is 3, b is minus 3, and c is minus 6. So the part A is done. So now the part B is find a simplified expression for f inverse of x, the inverse of f of x. So we have to find the inverse of a function f of x. So to find the inverse, we can start from here because we already switched our f of x into this form. So we have f of x equals to 3 times x minus 3 whole square minus 6. If we have to replace our f of x with y, so y equals to 3 times x minus 3 whole square minus 6, and we have to make the x subject from here. So if you take minus 6 to the left, so it will be y plus 6 equals to 3 times x minus 3 whole square divided by 3 on both sides, so y plus 6 over 3 equals to x minus 3 whole square, and if you apply the square root on both sides, then it will be x minus 3 equals to plus minus root of y plus 6 over 3. If you take minus 3 to the right, then x will be 3 plus minus root of y plus 6 over 3. Now you know that in the question it's given that the x is more than 4. So if x is more than 4, we should consider the positive root to make the value of x as more than 4. So it will be x equals to 3 plus root of y plus 6 over 3. Now if you replace your x with f inverse of x and y with x, you get your inverse. So this is f inverse of x. Now the next part is determine the domain and the range of f inverse of x. So since the domain of f of x is x greater than 4, so it means the range of f inverse of x should be greater than 4, because if the domain of f of x is the range of f inverse of x. Now we need to figure out the domain of f inverse of x. Okay, since the domain of f of x is x greater than 4, so if you put x equals to 4 into this function, when you replace your x with 4 over here, and if you work out this, it will be minus 3. So that means f of x should be greater than minus 3 is the range of f of x. So since the range of f of x is greater than minus 3, so the domain of f inverse of x domain of the f inverse of x, x greater than minus 3. So this is the domain of f inverse of x, because the domain of f of x should be the range of f inverse of x, and the range of f of x should be the domain of f inverse of x. So I'm signing off for now, and we'll do the rest question of this paper in the next video. Thank you.